can prevent the loop in the layer 2 network, the switch network, but the STP have shortcomings. The conversion speed of the STP is so slowly. So the IEEE introduced another protocol, the rapid STP, okay, the rapid span tree protocol. The name indicated this span tree protocol is rapid. Then the network convergence is more quickly. And in this chapter, we will compare the ITP and the STP, how ITP is worked, what makes ITP more quickly than the STP. And then, secondly, we will discuss how to configure ITP, okay? And then first, the shortcomings, the disadvantages of the STP. The major disadvantage of STP is convergence time. The network running STP is so slowly, okay? It needs 30 to 50 seconds, okay, to make the network converge. And the ISTP introduced some mechanism we called PA mechanism, proposal and agreement mechanism, can make the network converge more faster. And how this mechanism is worked, we will discuss later. Okay, and ISTP also introduced some features, many features, to make the network converge more faster. Okay, first, the ISTP introduced more port laws. As we know, in the STP, there are only 3 types of ports. First, the root port, okay? And second, the designated port, okay? And then the third is the blocked port, okay? And then in the ISTP, the blocked port is divided into 2 types. One is alternative port, and another is the backup port. The alternative port, you can see, the alternative port is a backup port of the root port, okay? Is an alternative path for the root port. When the root port is done, or this link is done, then the alternative port will be up, take as another path to the root bridge, okay? And then, what is the backup port? The backup port is an alternative path to a network segment, not to the root, okay? You can see, if this designated port is done, then this backup port should be up to connect to this network segment. So the blocked port is divided into 2 types, okay? And then when this direct connect link, for example, this root port is done, this switch did not need to recalculate. This switch can immediately make this interface, this alternative interface up to make the connectivity of the network, okay? Okay. This is the port law, one change of the STP to ISTP, okay? And then another feature is the edge port. As we know, the STP is to avoid loops in the network, but in the network, many ports of the switch is connected to PCs, to servers, to printers, and so on. That's not network device. That's the terminals, okay? So this device will not causing loop, okay? So on this port, on this type of port, did not need to doing STP calculation. So the ISTP introduced a feature we called edge port. And you can configure this port as the edge port, and then this port will not take part in the STP calculation. Okay, and this port, when some device connect to this port will go into the forwarding state directly. They do not need to waiting 2 forward delay time. Okay, that's 30 seconds. You do not need to waiting 30 seconds. And then after connect, then can sending data, sending and receiving data immediately. Okay, this is another feature introduced by the ISTP, okay? And then another change of the ISTP is the port status. As we know, when in the STP, when the interface, there are 5 status. First, disable when the interface is down, and then blocking, and then listening, and learning, and then forwarding. Okay, this is the 5 status. In the listening, calculate the STP. In the learning, of course, waiting for the STP to finish, converge, and learning MAC address. So the ISTP think about this status carefully and find all these 3 status did not forwarding data and only sending and receiving the STP BPDU. Okay, so all this status put into one status. This 3 status in the STP. Now it's one status in the ISTP, the discarding status. Okay, then the learning status, then the forwarding status. Only 3 status now ISTP. Okay, and then another change in ISTP is to change the BPDU format. Okay, in the STP, this is the format of the STP. Of course, in the previous, we have divided this STP BPDU into 3 segments. Okay, the first segment is the assistant information such as the protocol ID, protocol version ID, and so on. Okay, and then the second is used to calculate the best path. Okay, the second segment. Okay, there are the 4 fields, and the third is the timers. Okay, is the timers, and then the ISTP. Of course, the version. This is STP, and the version is different from the STP, and the flags of the ISTP is changed. In the STP, in these flags, only 2 bits is used. That's the TCA and the TC bit. Only these 2 bits is used. And then in the ISTP, all the 8 bits is all used. Okay, this is the agreement and the proposal bit. Yeah, this 2 bit is so important. That's because the ISTP introduced the PA mechanism, proposal and agreement mechanism, just using this 2 bits. Okay, using this 2 bits, and the rest of the bit is used to figure out the status of the interface and the port lower of the interface. Okay, this is the ISTP's BPDU. Okay, ISTP's BPDU. The flag of the BPDU is changed, introduced more bit to figure out the status of the port. Okay, and then when will the switches, non-root switches, sending out the BPDU? As we have learned in the STP protocol, only the root switch, for example, the switch A is the root switch. The root switch will create a new BPDU every 2 seconds. That's the BPDU timer, okay? Every 2 seconds. And other non-root bridge, okay, other non-root bridge only can receive the BPDU from the root port. When the switch receiving the BPDU from the root port, then the switch can create a new BPDU and then sending to other interface. Okay, this is the process of STP, but in the ISTP, this rule is changed. Okay, all the switches will generate their own BPDU at a higher time. Okay, if not, this switch did not receive the BPDU from the root bridge. This switch can still sending out BPDUs on other interface every 2 seconds. Every 2 seconds. Okay, this is the one where the ISTP BPDU sending out. Okay, and then this is an example. how the ISTP is converged. Okay, this is the example network, example topology, okay, topology. And then when this 3 switch is power on, then initially they did not communicate each other. Okay, and then each switch will regard itself as the root. Okay, because it's the root, so each switch will sending out a BBDU. Okay, of course in this BBDU, all the switches will regard itself as the root. Okay, then switch A and switch B will exchange their BBDU. Okay, but after the change of the BBDUs, then switch B and switch A will know each other who is the neighbor switch's priority in the BID, okay, BID. And then they will compare each other. Who is the better? Who is the better? Of course, we can see the priority is the same. And then the MAC address, okay, the first 3 bytes is the same, and the 4th byte, this is small. So smaller one wins. So the switch A will be the higher priority, okay? Then switch A will be the root, and switch B will not be the root, okay? Then if they know each other, then the switch A, because switch A is the root, so switch A is still sending out BBDUs, but switch B will hold on, will not sending out the BBDUs back to A. And when the switch A is sending out a BBDU, the flags in the ISTP BBDU will set the proposal bit. The proposal bit. Proposal bit means the root on this interface, root bridge on this interface, will not wait 30 seconds, okay? Will not wait so much time. The proposal means you prepared, I want to enable this port to forwarding date immediately. If you are ready, okay, then if the switch B received this proposal BPDU, then switch B first will block all the other interface, okay, and then sending back an agreement. Okay, this BBDU is sending back, and on this BBDU, the agreement bit in the flag field, the agreement is set to 1. This BBDU means the switch B said all other interface is put into the block state, and then you can enable this interface to forwarding the data, okay, and no loop will happen, okay. So after the switch A received the BPDU agreement BPDU, then this port will put into the forwarding state directly, not waiting 30 seconds. Okay, this is different from the STP protocol, span tree protocol. Okay, so make the ISTP converge quickly. Okay, after the switch A and the switch B have finished the negotiation, the switch B, of course, all the other interface in the block state will also negotiate with the neighboring switches. Of course, such as switch C, switch B and switch C will negotiate each other. And switch C and switch B also will negotiate each other. And then after the calculation, all the lower of the interface will be calculated and put into the certain lower and the status. Okay, this is the ISTP converge process. Okay, and then if some error will happen in the network, then what will the ISTP do to converge the network? Okay, first, if the root is failed, we compare with the STP. In the STP, when the root is failed, then all the other switches should wait for the how many time? For the maximum age, okay? Maximum age. Because the root ever have happened the BPDO, ever have sending the BPDO to this non-root switches. And this non-root switches, this BPDO will be varied for a long time, the maximum age, that's a 20 seconds. And only after 20 seconds, then the switch B and switch C, the non-root switches will realize, will knowing the root bridge is done. So the switch B and the switch C will recalculate. This is STP, okay? Of course, the calculation of the STP also need 30 seconds. So need 50 seconds. But in the ISTP, it's different. They did not, switch B and switch C, did not wait 20 seconds. They only wait the hello time, that's 2 seconds, multiply 3, okay? That's 2 seconds, multiply 3 equals 6 seconds. And then, after 6 seconds, switch B and switch C will realize that switch A is lost. And then, they will negotiate. Of course, the ISTP calculation did not need 30 seconds, okay? There are peer mechanisms. Usually, I think if two switch during 2 seconds, then finished. So the convergence is more faster than the STP, okay? And then, if the topology is changed, then in the STP, we know if the topology is changed, so the MAC address table in each switch is invalid now, but the MAC address will not deleted immediately. So we need a TCN process, okay? Topology change notification, and then through the OS network, and then reach the root, and then the root will sending out a BPDO, set the TC bit, okay, to inform all the other switches, inform all the networks that topology is changed, then delete the MAC address table, okay? And in the ISTP, this process is changed, is improved. The switch that detects the network is changed did not need to sending out information to the root. The switch sending out the topology change BPDO immediately, okay, did not need to inform the root, but sending out the topology change information, topology change BPDO immediately to all the other switches. Then all the other switches will know that the topology is changed, and then delete the MAC address table, okay? This is a process when the project is changed, then the MAC address needed to refresh, okay? And then another, the STP interoperation. As we know, now STP, the standard STP, is the version 1 of the STP, and now the RSTP is another version, okay, is another version. And the mechanism of RSTP has many differences than the STP, and the ISTP converges more faster. So if when in the network, there are some device running ISTP and some device running STP, then what will happen? Okay, the ISTP is compatible with the STP, okay? That means when a switch A and a switch B is running ISTP, okay? It's running ISTP. They are negotiated with the ISTP. But the switch C is running standard STP. So the switch C can only process the version 1 BPDO, okay? So when the switch C is sending out the BPDO, then the switch A and the switch B will detect this is a version 1 BPDO. So the switch A and the switch C will change this interface status, okay? This interface will running in STP. and all the other interface still running in ISTP. Okay, so the switch C, we are running STP with switch A and switch B, and between switch A and switch B, we are running RSTP. They are compatible, but this scenario not recommended. Okay, not recommended, because the STP, if the device is supporting the ISTP, please enable it RSTP, because ISTP converges so faster than the STP. Okay, the ISTP have advantages. Okay, and then the configuration of the ISTP. First, as the STP, much like the STP, the ISTP also is running automatically. If you not configure it, then it will operate running automatically on the switch in a switch network. And as we know, the Huawei switches support 3 versions of STP: STP standard STP, ISTP, and MSTP. Okay, and by default, the Huawei switch running MSTP. So if you want to running ISTP, then just configure ISTP, so STP mode ISTP on the switches. Of course, if you're running ISTP, then all the switches should configure this command. Then the switches will negotiate with the ISTP, RSTP, BPDU. Okay, this is the mode. Okay, and then after the configuration, okay, we can check using display STP. Then we can see the mode is ISTP. Okay, and then we can see the BID of this switch and the root BID. Okay, of the network, and some other timers and so on, some other informations. Okay, and then if you want to add features to the network, to the switch, for example, you want to configure this interface as the edge port, just on this interface use the STP edge port enable. Okay, of course this switch should configure in the ISTP mode, then configure this port as the edge port. And after configure of this interface can connect it to the host. Okay, and when the host connected, then this interface will enable the forwarding data immediately. Okay, but the edge port, if you configure this interface as the edge port and then connect it to a switch, okay, when the switch received, when the edge port received the BPDU on this interface, okay, this interface will turn back to the normal switch interface. That means lose the feature of the edge port. This command can set the interface to be the edge port, but if you want to set all the interface of this switch to be the edge port, you can use this command, STP edge port default. But be careful, such as this interface is connected to a switch, a network device. So this interface should not be the edge port. So on this interface, you must configure STP edge port disable. Okay, make this interface running STP and avoiding loops between the switches. Okay, and then the ISTP also introduced some protection. Okay, some protection mechanism. First is the BPDU protection. What's the BPDU protection? The edge port will not receiving BPDUs. That means the host connected, the host will not sending BPDUs. Okay, only the network device, that's the switch, will sending BPDU. So if on the edge port the BPDU is received, that means this port must be misused. Okay, that means this port configured as the edge port but connect to a network device. So by default, the switch will put this port back into a normal port and then doing the ISTP calculation. But if you think this is misused, so you may need to disable this interface. You can configure STP BPDO protection. Then after configure this, if a BPDO is received on edge port, then this port will put into an disable state. Okay, we are not forwarding any packet, any frames. Okay, and then there's another mechanism we call loop protection. Okay, what's loop protection? In the ITP calculation, then the network will calculate without a loop, but sometimes maybe such as this link is in an error state. In this error state, for example, this link is a unidirectional, such as the frame from the switch C can reach switch A, but the switch A cannot sending frames to switch C. Okay, in this state, the switch C cannot see the BPDU from the root, so the switch C will enable another calculation, then this put into the forwarding state. And of course, if this port cannot forwarding any frames, then that's right. Nothing will cause a problem. But if it's unidirectional, then the packet can be looped this direction. Okay, of course this direction cannot looped. Okay, so this is a problem. So you can enable the loop protection on the switch C. On switch C, if the switch C cannot receiving BPDU from a root port, then the switch C will not put this root port into the designated port status. Okay, will not get the lower of the designated port, but put into a disable state. This is a root protection. Okay, to preventing the condition that something is error, such as the unidirectional network lines. Okay, and then after your configuration, you can check using the display STP interface. Okay, see the status, STP status of this interface. And if you enable the protection, loop protection, then in the protection type, there's a loop. Okay, indicates that loop protection is enabled on this interface. Okay, and then we finish this chapter, and then there are the questions. What is the purpose of sync when occurs during the ITP proposal and agreement process? In the ISTP, the proposal and the agreement process is to make the convergence of the network faster. Okay, the root bridge we are sending out the proposal, and then the non-root bridge we are sending out an agreement. Okay, but before the non-root bridge sending out the agreement back, all the other interface we are put into an blocking state. Okay, put it into a blocking state. This process we call sync. Okay, sync. And the sync process, I think, after the agreement, this link will put into a forwarding state. Okay, if not, all the other interface not put into the block state, then maybe we are causing a loop. Okay, we are causing a loop. So the sync process just to avoid the loop in the PA process. Okay, proposal agreement process. Okay.